In this exercise, we're going to be looking at the code for seeing if a number is a prime, and we're actually going to do that through a TDD, BDD approach, and we'll take a look at performance, and we'll end up with code that has some tests. Alright, so let's get started. Alright, so let's create a directory, well named. It's a prime. Okay, let's go into that, and let's start off with our test. We're using our spec, so we've got a spec file here. So I'll put it in the minimum to get that started. And that would be that. Let's split panels, run that, and it passes. That's good. Alright, let's put some real code in here now. So let's see, I usually do something like source equals, result equals, the function that I'm going to create, and what my expectation is. And for one, it's going to be pretty simple. It should certainly be true, which shorthand for that is to be. Alright, we're going to need our method, so we know that without even running it. So let's make it pass. Alright, kind of skip the failing test there, because it was obvious we'd need that method. Alright, so now let's do another number now, and let's run that, and it'll actually still pass, because 2 is also a prime number. So we need to get to a case that's not going to be that. So let's start naming these. The first one was 1, and then next one was 2. I actually misnamed it here, but the one we want to concentrate on is the 4 here. So that one should not be a prime number, so obviously it's going to fail. Alright, so now we need to put in some real code up here. So to make that pass, I mean, we could do a little bit of a hack, but let's just put in the algorithm that we know. We're going to go from 2 up to the number -1 and see if the number's divisible by any of those. So we'll call that our divisor, and we'll set something if there's no modulus for dividing by that. So we'll set this thing called prime. Let's set it up here. Start off with it being true, and then we'll set it to false if we find the exact divider. So, and then we need to return it. Alright, I think that all works. Let's run that. Okay, good. Alright, now another case. So, we could try doing 5. See, that's kind of a flip, perhaps, just in terms of what we need to test. So let's see if 5 returns to being true. Yep, it does. Alright, so let's jump, let's see, well, 6 would be not true. 7, let's try 6. So that should be not there, and that should be 6. Okay, let's run that. Okay, well, it seems like our algorithm does seem to work. Let's just go with the assumption that it is. So let's do another set of tests here, and let's do some tests that measure the performance. So we'll do some measured runs here. So let's do some timing. And in Ruby, that's pretty easy. Actually, we can use the benchmark library. So let's put that in here, and it's benchmark.measure, and then surround the put a block of code in there. All right, and you need to do it a lot of times, because once with a simple thing like this is never going to be enough. So I'm just going to throw it right up. Something as simple as this, I'm going to put it 50,000 times. I'm going to look at this source. I'm going to declare this ahead of time, a bunch of numbers that I want it to do. I don't just want it to do one number. Let's have it do a little bit more computation here. So I'm going to give it 7 numbers, and I'm going to set that outside of my benchmark there. But within each time, I'm going to go through each of those source numbers, and I'm going to figure out whether a prime is true or false. So our results, I'll start off with it there, with it being empty, and then I'll add it in as I figure each one out, whether it's true or false. So I'll end up with an array of true falses. Alright, so that will be that test. And yep. Okay, oh, sorry, I was a closed brace, not an end for the end of that block. Alright, get it indented correctly. Alright, I think that should be good. Let's try running that. Alright, benchmark. Well, we need to include the benchmark library, so put that right at the top, require benchmark. stick that in. Okay, let's run that. Okay, that passes. So it's doing it a bunch of times. Actually, I need to give us the output. So let's just use pp for pretty print. We've got to require pp up here for that. So let's do that and run that. Okay, now we got some timing. Let's see, real is 0.93. Alright, so let's do another case. Let's do a different approach. Let's see if we can perhaps improve the timing. So let's call this, for simplicity, method 2. And we'll call this prime underscore v2. Just for want of a better name, just for this purpose. Alright, so we know we're going to have to create that method. So let's just cheat a little, copy and paste. And we'll call this v2. Alright. So what can we do here? Well, maybe we only need to go up to through half the numbers, because anything over half is never going to be divisible exactly, because we've gone down to 2 for the divisor. So we could go up to that, missing a paren. Alright, so there's the 2 of them. A little bit hard to see which is which, so let's do a dashed line between each one. So we could just do that very tersely like that. And run it. Okay, now we got 0.77 and 0.51. Okay, let's do it again. 0.86, 0.54. Okay, and third time 93.55. So that's pretty consistently faster. That's good. So what else could we do, or how else could we make this faster? Let's just describe what that was. That was half the numbers. So let's do another example here. Let's do this for method 3. And maybe method 3 we could try not even going through like the loop, try and return early in a couple of cases, like for evens, say, at least. So instead of doing all of this, we'll call that v3, and we'll go up here again. Take this, make it v3. Okay, so before we even go through that loop, maybe we could just say, maybe just return true, obviously, if, sorry, false for evens, if number mod 2 is 0. So just put that right at the beginning. Seems like it would eliminate a lot of checking, perhaps. Sorry, not 3, 32, v3. Okay. Okay. 5, 6, 5. Not really. Not really much of an improvement. Yeah, maybe a little, but very little. So that really didn't help a lot there. Certainly not compared to the previous one. But I still think we can do better. So let's do a fourth method here. Let's call this method 4. And I didn't think initially we could do this. It does seem that we can actually go up to the square root. There's actually a new method in Ruby 2.4.1 that's going to be kind of handy to do this in. So let's call this method 4. Go up to there. And familiar. Let's go back to this method we had in method 2, because method 3 didn't really add a lot. So let's sort of step back to step forward. Let's shrink this up just so it's easier to read for us on the screen. Alright, method 4. So the way of doing this is we use the integer class, and it's got a method square root. We pass in the number we want the square root of, and it'll have to think for a minute if it's going to be okay with an integer rounding down, and it would be. If you thought of like 49, 50, and 51, thought of the edge cases, that'll work okay. So yes, is this, and hold on a sec. Gotta put in. You know, one thing we're not doing is actually validating the results here. So we've got our timing there, but we actually want to have our expectation. Kind of jumped ahead a little bit here for that set of numbers. We assume they all worked, even though we only tested up to 6 initially. So 5 should be true, 9 should be false, 21 is false, because it isn't a prime, 25 isn't a prime, 30 isn't a prime, 53 and 101 are. So false syntax not quite right here. I think I want to have, a second, let's see what it's doing. Oh, this is actually, oh, this is here. Sorry. Okay. Missing a paren. Hard to spot sometimes. Okay, so that improved it. That definitely improved it. So that was a good one. We should actually put that expectation down in the other ones as well. So let's do that. Make sure that all these different methods, a bit late in the day, but a little bit of confidence there. Okay, no, they actually all did pass, so that's good. And yeah, that one keeps being faster, which is kind of nice. We've got 4 different tests here. And so here we got our 4 tests. And let's see what else could we refactor. Maybe we could bring that expectation up here. Just make it a lazy evaluated expectation. Call it expected. And we'll set it to that. And then we can use that here. It was expected. And here. Oops, mistype. Expected. Okay, and here. Expected. I'm being a bit lazy there with my typing. There we go. Alright. That should still work. Let's make sure it does. You never know. Okay, that was good. Alright. So we've tried that up a little bit. We've got up 50,000 at every example. We've got that magic number there, so maybe we can do something about that. And we've got source, so let's actually fix source first. So let's do that. So we are not hoping our typing or copying and pasting is good. We've actually defined it. Same one for all of them. Tries it up a little bit. Okay, that's good. And let's see. Leave that 50,000 for now. Normally I would try it. Okay, that looks pretty good. Alright, thank you.